Next example. This is motion on an inclined plane. I love inclined planes because they're really challenging questions. They're great, okay? My favourites. Motion on an inclined plane. Yes, let's get into this. You want some of this? Yeah, let's have some of this. So, block of mass, 1.6 kilograms, is held at rest on a rough slope, okay? Inclined at an angle of 45 degrees to the horizontal. Coefficient of friction between the block and the plane is 0.25. The block is released from rest and slides down the plane. Find the acceleration of the block first of all. And then you've got to find the velocity of the block after 2 seconds. Let's get into this. Maybe you just pause the video, do a force diagram first of all, and then unpause it when you think you're finished, right? Maybe quick. So I'm going to do the force diagram now. Quick. Pause the video. Where's that mouse? Where's the pause? Got it? Good. Right. Here's the force diagram, one which I prepared earlier. Okay. Now, granted, I'm going to add a little bit more to it, but the very minimum, you need to have something like this. All right. So, inclined plane at an angle of 45 degrees to the horizontal. Object of mass 1.6 kilograms, so weight 1.6 g vertically downwards. Normal reaction. Remember, it's always perpendicular to the direction of motion, or in this case, the actual plane itself. In all our cases, we deal with mechanics. It's essentially the same thing. The direction of motion is the same as the surface in which it's resting on. Okay, but short, r is perpendicular to the plane, and then it's sliding down the plane. Let's highlight that bit, shall we? It's sliding down the plane, and why not? Why not? Okay, it's surely going to slide down the plane unless something else is preventing it. Okay, as long as the plane is steep enough. All right. So I've just put an acceleration arrow there to indicate it's sliding down the plane. Now, the importance of getting the direction of motion correct is really significant. It tells you where to put friction. Friction will always oppose the direction of motion. So if it's moving down the slope, the frictional force F is going to be up the slope like that. Okay, now I'm just going to adjust to it a little bit. I'm going to add this triangle there. That's what I call the weight triangle, right? And you can use similar triangles to show that that angle there is also 45 degrees. All right, sorry if it's not too clear, but that's 45 degrees, people. And what I've done is I've used this weight component triangle to help work out the component that is parallel to slope and perpendicular to slope, because you can treat these like vectors, right? If you've got one vector in that direction there, then you can also split it up into 2 different component vectors there and there. And the way we do it is we split up into a right angled triangle, always using the given force as the hypotenuse, big hint for you there, and then you've got the adjacent and the opposite for the various components, the parallel and perpendicular to the plane. All right. So 1.6 g is going to be in that direction down the plane, and then in this direction, effectively in the opposite direction to the normal reaction force. Did you have that force diagram? Well done if you did. If not, you really need to get that sorted. Okay, let's be honest. You really need to get that sorted. If you don't have a correct force diagram, you're going to be lucky if you get the whole question correct. Now, where to go from here? We need to resolve. Resolve horizontally and vertically when it's on a horizontal surface, but when it's on an inclined plane, resolve parallel and perpendicular to the slope. You choose which one you want to do. Okay, I often go for perpendicular first, if I'm honest, because there's less going on in most circumstances. There's less going on, and hopefully you can see quite quickly I've got just one unknown. Okay, I've got R, and I've got the weight component there, which we know. So I've got just one unknown. Because there's no acceleration perpendicular to slope, these two are going to be balanced. They're going to be exactly the same. So you can write R is equal to this weight component here. That's adjacent to 45 degrees, so cosine 45 degrees. So that's 1.6 g cosine 45 degrees. Okay. And as you should know, cosine 45 degrees is root 2 over 2. So we could write that as 0.8 root 2g. So I just put the numbers before the g. Okay. Yes, you can work it out a bit more precisely, but that's good enough for the moment. Okay. Now, before we go on, I could do something else. See this here? coefficient of friction is 0.25, 1/4. I can actually work out what F is straight away, can't I? Because I've labelled F there as the frictional force, but I can actually work it out straight away. I'm going to do that. Yeah, I'm going to do that. So I've got, let's do it here. I've got F is equal to mu R, so let's write it as 1/4 R. Sorry for the mixture of decimals and fractions. I do that sometimes with mechanics, okay? And so you've got 1/4 of that essentially. Well, 1/4 of 0.8 is 0.2. Okay, so you've got 0.2 root 2 G. So that's an exact expression for the frictional force. Okay, you can work it out as a number if you want. I'm just not going to. Okay, the less I can pick up a calculator, the better. Okay. Oh, did I just say that? Yeah, I did just say that. Calculators are great. They're useful. Okay, but they're not absolutely essential for most of the question. Okay, and you do well to try and do as much as you can without a calculator. All right, that's my advice to you. Next, we'll resolve parallel to the slope. Okay, do you like my shorthands for parallel and perpendicular? It's just that with resolving on inclined planes, you don't really want to be spending time writing parallel out in full or perpendicular out in full. Okay, so I'm going to choose downwards as being positive. Can you understand why that is? Because it's moving downwards, isn't it? Okay, so the components that's going to be downwards is going to be the weight component. That's 1.6 G. This time it's sine 45 degrees. Okay, whoops, beg pardon. Sine 45 degrees, that's better. And then opposing that is the frictional force, isn't it? So subtract the frictional force. Well, hang on, we know what that is. It's this. 0.2 root 2 G. Okay, so you can see all written here, but we've got no unknowns there. These are just numbers. We can calculate those, and that's equal to the mass times acceleration, mass of 1.6, and A, the acceleration. The only thing we don't know is A, right? So that's quite nice, isn't it? What you want to do is work out the left-hand side, and then just work out what A is. While you're doing that, I'm just going to simplify this a little bit. Okay, hopefully you got that down. You should be aware that sine 45 degrees is also root 2. If you're not aware of these interesting facts, then learn them, is my advice to you. Okay, so that would be 0.8 G root 2, subtract 0.2 root 2 G. Okay, I'm going to simplify this a little bit more because I kind of like doing this sort of stuff. I like getting an equation and then just simplifying it as much as possible. So that's 0.8 G root 2, 0.2 root 2G, same thing, isn't it? Root 2G, G root 2. So that's going to be 0.6, isn't it? Root 2G equals 1.6A. Okay? Now, because I want an answer to two significant figures, I'm going to have to work out what that is. So you've got 9.8 is G, always use 9.8 of course, in the syllabus that we're using it, well I'm using anyway. So 9.8 times 0.6, and then here we go, multiplied by square root of 2, yeah, and that's when you're using a rational value of course, divided by 1.6, and what have we got, 5.2. Okay, so I've got a value of A equals 5.2 meters per second squared to two significant figures. Remember, if you're using G as 9.8, two significant figures is how you should round it. Okay, all okay with that? In case you want to get a screenshot, just come out of picture. Okay, there you go. If you think about get that, obviously you rewind the video and have another go. Right, so we've got A is 5.2. What I'm going to do is I'm just going to get rid of those annotate. Whoa, my diagram's gone. I'm not going to do that then. I'm going to use the larger version of my board rubber and just rub these bits out here, okay? It's weird that those are counted as annotations, isn't it, really? But there you go. Yeah, because I don't actually need a lot working anymore for part B. All I need really is the A equals 5.2. Now those who've been watching my calculator, who would watch my calculator? Maybe you rewind the video and have a look, okay, just to see if I'm telling the truth. Of course I am, but those who've been watching will see that I have not reset it, I've kept the value of A in it, because I know I'm going to have to use it again. Right? That's another bit of advice for you, okay? Once you've worked something out in the calculator, don't immediately reset it unless you have to, okay? Keep it in there because you never know when you have to use it again. find the velocity of the block after 2 seconds, because that's going to be dependent on the acceleration, isn't it? Okay, how far it moves and how fast it gets up to is going to depend on the acceleration. Find the velocity of the particle after 2 seconds. Okay, the block particle. Sorry, I mixed my words there a little bit. So the acceleration is 5.2. T is equal to 2 seconds. All right. We've got to work out what the final velocity is. So letter V is what we use there. Do you know what's missing? What we need to know? Okay. S? No. U? Certainly. Released from rest. Okay. Again, important to read the whole question so you can understand fully what's going on. It's released from rest. So U is 0 meters per second. And then we've got to work out what V is. Equation, V equals U plus AT. I think that will do, won't it? Okay, so let's just get rid of the question mark. V is equal to U plus AT. So V is equal to 0 plus A times by T. So that's, I've got my calculator, 5.2 multiplied by 2. So just multiply it by 2, okay? And actually, this and my calculator does give me the same answer, even to 3 significant figures. Okay? But if you've been consistent is the word I'm looking for, then you might want to round it to 2 significant figures. Okay, and let's just not forget, because it is a velocity, some units should go on there as well. Okay, I'm hoping you found that example interesting. All right, do some more inclined plane questions because they really are fun, they really are challenging. Okay.